Let's do this question. The question is asking determine the reactions at the supports, and we have this 400 Newton meter acting Newton per meter acting on this one, right? And this means they are showing that equal forces acting on everything. So since this one is right here, and let's see what we can do. So for this one, there's only possible one way. This is going to be acting this side, and therefore this is going to be acting this side. For this one, A is going to be acting directly to this side, and we have to know this is 90 degree. Therefore we know that for this one, the horizontal component is going to be acting this way, and vertical component is going to be acting this way, and horizontal component is going to be acting this way. Since if you see this is, so we have this information right here, 3, 4, 5, but we know this force is acting directly perpendicular to this one. So it's going to be extend like this. Therefore what we know is this is going to be making the same triangle, but the distance are going to change. It's going to be 3 here and 4 here, and wait a minute, so 3, this is going to be 3, 4, and this is going to be 5. So that's how we find this one. Since we have all the, and this one is saying Newton per meter, so they are representing that equal force acting on both sides. So I raise this one and put it differently. Okay, so equal force acting on this one, and they said Newton per meter, so it's going to be 1/3 of this 1 meter. So 1/3 of this one, 1/3 of this. Both of them are equal force, so I put it both of them F. This is Bx, By, and the vertical force is going to be Ay, and this is going to be Ax. So let's calculate the moment around B. The total moment around B is going to be 0. In statics, the total moment is 0. And if I take B, I will get rid of this Bx and By. This one we know it's 2 meter distance from here because this is 1 meter, right? So this is going to be 2 meter distance. And we also know this is 1 meter distance, so this is 1 meter, so this is going to be 4 meter distance. So first of all, if I take this F, let's take the counterclockwise positive. So if I take counterclockwise positive, from this one, if you see this is pushing the object down, so this is acting counterclockwise. So therefore this is positive, and the distance is 2. So F times 2 plus this is also acting counterclockwise. That's why I put plus here, and this is going to be same F, but distance is 4. And what else? What are the other horizontal vertical components we have? We can't take the horizontal component because this is directly toward the axis, therefore the horizontal component is 0. We can take the vertical component. This is going to be Ay sine theta. So this is going to be 5, and this is going to be 4, right? Let me write this again. So this is going to be 4, this is going to be 3, and this is going to be 5. So if it's a sine theta, it's going to be minus because it's going upward. It means it's moving this object clockwise. Therefore, this is minus, and a sine theta means opposite of adjacent. Opposite is going to be the y-axis. It's 4 over opposite over hypotenuse is going to be 4 over 5. 5. The total moment is going to be equal to 0, and the distance is 6 meter. As we see, this is 3 meter, 3 meters. It's going to be 6 meter, and all of them are equal to 0. We can calculate the force by using the triangle formula. We know this is 400 Newton per meter acting on here, and if we find the area of the triangle, it's going to give us the force. So to find the area of the triangle, I have to use half time width time height. Half time width is going to be 3 meter, and the height is, we know, 400 Newton per meter. So if we calculate, it's going to be 600 Newton. So I had to apply this one here. It's going to be 600 times 2 plus 600 times 4 is equal to, I can equalize this to 6 times 4 is going to be 24, 24 over 5a. So finally this comes out to be 1200 plus 2400 equal 24 over 5a, and if I solve this one, it's going to be a is equal to 3600 times 5 over 24. So the final answer is 750. A is equal to 750 Newton. So we found the A. So since we have A, we can calculate AY and AX. But let's find the B components. So determine the reactions at the supports. Okay, let's do the B components. So to find the B components, I have to take the moment around A. So if I take the moment around A, the total moment is going to be 0 in statics. It's going to be, and let's take now I am taking the clockwise positive. If I take the clockwise positive, it's going to be the same thing, but it's going to be opposite side. So from here, the distance of F is 2 meter. So we can say F times 2 meter, and from this side it's clockwise because this pushing this object down, so it's clockwise. So F times 2 plus other one also clockwise, and F times 4. And if you see By, it's pushing this object upside, so it's gonna be counterclockwise. Therefore it's negative right here. It's going to be By times 6 is equal to 0. So we know this is going to be 600 times 2 is going to be 1200. It's going to be 2400 equal to 6 By. Therefore By comes out to be 600 Newton. So we have the By. Now I can calculate Bx. So to find the Bx, I have to let's do the sum of f of x. In static, sum of f of x is equal to 0, and I'm taking this direction positive. If I take this direction positive, this ax is going toward this direction. Therefore ax is positive, but it's going to be ax cos theta. Ax is going to be a cos theta because we know the angle. So cos theta is going to be adjacent over hypotenuse. We know adjacent is 3, so a times 3 over 5. And bx is opposite side, therefore it's going to be minus bx is equal to 0. We know the a already, it's going to be 750 times 3 over 5. equal to Bx. If I calculate Bx, it comes out to be 450 Newton. This is my final answer. I hope you guys liked this video. See you next time.